Hello everyone, and in this lecture I will introduce all the essential kubectl pod commands that are applicable to all three exams: Certified Kubernetes Application Developer, Certified Kubernetes Administrator, and the Certified Kubernetes Security Specialist. So the first command is kubectl get pods, and this command lists all the pods in the default namespace, showing basic information like name, status, restarts, and age. The next command is kubectl get pod followed by the pod name, and this command retrieves detailed information about a specific pod identified by its name, including labels, annotations, containers, images, node, and the current phase. Then comes kubectl get pods -n followed by the namespace name, and this command lists all the pods within a specific namespace, which is useful in larger clusters where resources are organized across multiple namespaces. So first you will do kubectl get ns to list all the namespaces, and then once you have identified the right namespace, then you will issue this command to get all the pods for that particular namespace. Then comes kubectl get pods followed by -a. So this is uppercase, and this command lists all the pods across all namespaces in the Kubernetes cluster. The -a flag, which is shorthand for -- all namespaces, allows you to see pods from every namespace in a single view. So for the exam, most likely you will be using this command a lot to basically see all the pods. But in a real world production cluster, maybe you will be using it less because this may give a huge number of pods listing. Kubectl describe pod followed by the pod name, and this command provides comprehensive information about a specific pod, including configuration details, current status, recent events, resource usage, IP address, ports, container states, and the event logs. It is particularly useful for troubleshooting. So this is a very detailed command, and it will give you all the containers, all information, and it is like quite verbose. But this you will be using more for troubleshooting purpose. So even a lot of scenarios you have to find out which container runs in a particular pod for a container pod, and then you take the container name and then you issue some more commands for troubleshooting. And you will use this particular command kubectl describe pod name, and -n namespace name. So by default the previous command runs in default namespace, but you will most likely will be using this because most of the time pods run in specific namespace rather than the default namespace. Then we have kubectl get pods -o wide, and you have two options also. This is optional, so you can do -a for all namespaces or -n for a specific namespace name, and this will list. This command extends the standard pod listing with additional columns, including the pod's IP address and the node it is running on, providing more context about the pod's networking and placement. So sometimes we have to see which pod are running on which particular node. So let's say you have 3-node cluster and you have some affinity or anti-affinity rule. You will be using this command to quickly see which node the pod is running on. Then we have kubectl logs followed by the pod name, and this command displays the logs of the first container within the specified pod, which is essential for monitoring application behavior and identifying issues. And this also runs in the default namespace. So you can use kubectl logs pod name and the -n namespace name. Then you have kubectl logs -f followed by the pod name, and here also -n option is there, and this command follows the log output in real time, continuously displaying new log entries as they are generated, similar to the tail -f command in Linux. Then you have kubectl logs again -f, as I talked about. You have to give -n for the namespace name. Then comes kubectl logs followed by the pod name and -c for the container name. So in case you have a multi-container pod, first you will do a describe and you will find out the container name, and then you will use this command to find the logs of a specific container. So this command allows you to view logs from a specific container within a pod that hosts multiple containers, ensuring you are examining the relevant components logs. So for a single log container, we don't have to use. So we have one more variation: kubectl logs pod name dash c container name and dash n namespace name. So this will be most likely you will be 80 to 90%. You will have to have specified the dash n. And I was talking that if we just have one container, we don't have to give this. It will automatically invoke the right container. Then comes kubectl exec pod name followed by space dash dash and a command. This command executes a specific command within the first container of the specific pod, and that allows direct interaction with the container's environment for inspection or administrative tasks. So you can just give a pod name dash dash, and let's say you want to list out a file, you will say cat space slash slash the exact to the complete path to the file, and it will just execute that command and it will exit out of the container. So it is useful only for a single command execution, because it will not go in the shell or the bash. And then comes kubectl exec it. So this is interactive and tty. If you want to run some command, so you go pod name dash dash and you usually give slash bin slash sh or slash bin slash bash, and then this is how you can interactively get inside. So basically it's like a SSH login to a pod. Once you are in the pod, you can spend as much time as you want and run command. So this command provides an interactive terminal session inside a container, giving you full command line access to run multiple commands and use interactive tools within the container's environment. So previous command, single execution, this a long session. And then comes kubectl exec and the variation where we have to specify the dash n namespace followed by it pod name and dash dash command. And next command is kubectl port forward pod name, and then you have a local port on your machine and the pod port. This command forwards a port from your local machine to a specific port on the pod, creating a temporary tunnel that allows direct access to services running in the pod for testing or debugging. Next command is kubectl apply -f and the pod definition YAML file. So this command creates new resources or updates existing ones based on the configuration specified in the provided YAML file, supporting infrastructure as code and reproducible deployments. So this may be applicable in an exam in some scenario, but most of the time to save time you will be using the command line based approach. But this is in most of the production project, everything, the whole infrastructure is in the YAML file, and you use this command to apply whatever is in the YAML file. Next comes kubectl delete pod, and this is straightforward, and this terminates a specific pod identified by its name. Note that if the pod is managed by a controller like deployment, Kubernetes will typically reschedule a new pod to maintain the desired state. So what it means is, if the pod is part of deployment, even if you kill the pod, the deployment will again create a new pod just to maintain that total replica count. Next comes kubectl get pods followed by -- show labels, and this command lists all pods in the current namespace and displays their labels, providing visibility into how pods are organized and categorized. And if you give dash capital A, it will give for all namespaces. So those two are applies for almost all the pod commands. So you can have same thing as I talked about. So this is optional. You can give either -n for the namespace or -a for all. Then next comes kubectl label pod followed by pod name and the label key and the label value. And this command adds a new label to a specified pod or updates the value of an existing label, which is useful for organizing and selecting groups of pods based on a certain criteria. And next comes kubectl label pod name, label key, and you just have a minus or the dash sign. So if you just think of it as a minus, it's like a remove minus. So this command removes a specific label from a pod by appending a hyphen to the label key, and that allows for dynamic modification of a pod metadata. So it will remove the label. Then comes kubectl annotate pod name, annotation key and the annotation value. So this is label key and label value, but annotation has a different purpose. This command adds or updates an annotation on a pod, which is used to store arbitrary, non-identifying metadata that is not intended for object selection. So its purpose is basically to add some additional information. So some of the products, when they launch, when they have some deployments and all, they will have this annotation, which will not serve any purpose, but only to identify some extra information, some business related information that they want to convey to their audience. Next comes kubectl get pods -l label key label value, and this command, this is for filtering. This command filters and lists only those pods that have a specific label with a particular value, which is crucial for managing and monitoring applications based on their labels. Next command is kubectl top pods, and this command displays the real-time resource consumption metrics such as CPU and memory of pods in the current namespace, which is essential for performance monitoring and resource optimization. So you can, again, as I talked about, you can give a -n or capital A. Then you have kubectl debug followed by the pod name, and you can have IT for interactive and TTY followed by image and a different debug image. And this advanced command creates a new container within an existing pod for debugging purposes. It is particularly useful when original container lacks necessary debugging tools. Next command is kubectl get pods --field selector equal to status and phase not running. So this is just an illustration. So field selector can have different status or some other values. So in this particular example, this command filters pods based on their status phase, listing all pods that are not in the running state. For example, other states are pending. Not running means it will show all which are pending, succeeded, failed, or unknown. And this helps quickly identifying problematic pods. So if you can just remove not and just equal, then it will, let's say you want to running, it will just show the running. Or let's say you want to troubleshoot only failed, you just equal failed. Next command is kubectl get pods --sort by. Then you have this adjacent path .metadata .creation timestamp. So this command sorts the pod list based on the creation time, showing the oldest pods first, and this is useful for understanding the chronological order of pod creation. And next come kubectl get pods --watch, and this command displays pods and continuously updates the output when changes occur, and that allows real-time monitoring of pod status changes. So you can just space --A, and that will, you can watch all the pods across all namespaces. So, and you can give us -n for specific namespace also. Next comes kubectl copy CP and the pod name and the source path, which should be inside the pod, and destination path, which is on the local machine. And you can reverse the order also. Destination can be here and pod can be here. So this is source is here. You are copying from the pod to destination, and this command copies files between a pod container and your local file system. And this is helpful for retrieving logs or configuration files from the running pods. And then comes kubectl attach pod name. This command attaches to a running container in a pod, streaming its standard input output similar to Docker attach. And that's all.